This is called vertex form because you should be able to just look at this and see your vertex. So what is the x value of the vertex? 1. What is the y value of the vertex? 4. So inside with x always goes the opposite way. This graph has a positive 5 in the front of it, so will this be going up or down? Up. That's going to become useful later. So the axis of symmetry is the line that would cut this in half. Would it be a vertical line or a horizontal line? Vertical line. So we're going to have some vertical line. Since it's a vertical line, what point does it have to go through? The vertex, which is at what point? 1. So vertical lines are always x equals. It has to go through the vertex because the vertex is in the middle. So that's there. Looking at our picture, is this going to have a maximum or a minimum value? Minimum value, it's opening upwards. What point has to be at the lowest part of that quadratic? 4. It's a minimum, maximum, minimum, up, down, those are y values, so that's why it's y equals 4. The domain of all quadratics, how far to the left will this graph go? How far to the right? That's never going to change, so you don't need to worry about that. And then range-wise, where's the lowest point of this graph?
4.
4. It has to go to the vertex. Can it equal 4?
Yes.
Yes. And then with those arrows, how high up will it go? And we can never equal infinity. So that's what we did yesterday. And then you guys would go through and graph this. When you graph it, it's always find your vertex and then put on your sides. To put on the sides, the counting pattern for quadratic is always over 1 up 1, over 2 up 4, over 3 up, and so on. If you are going to change that, what part of the equation does that show up in? The very first thing. So since this has a 5 in front, whenever you have something in front, what part of the counting pattern does it change? The second part. So all you do is you then multiply. So then 1 times 5 is 5. 4 times 5, 9 times 5. So then your new counting pattern would be like over 1, up 5 on both sides. Over 2, up 20 on both sides. So that's what we did yesterday. Today we're going to go through a different version. Yesterday we looked at vertex form. So you guys know vertex form. You know that A is a stretch or a compression, and then what point is HK? Your actual vertex. What we're going to look at today, and this one you guys do need to write down, is standard form. So just write standard form and then copy down that equation. So visually, we know it's still a parabola because it has that x squared, but standard form, what doesn't it have? Parentheses. There's no parentheses. So this is like vertex form, but just multiplied out. So standard form is ax squared plus bx plus c. It has no parentheses. Things are written in order, so it's x squared, then x, and then just your number. Similarities. Do they have any variables that are the same?
Yes.
They have x, y, and then there's one more, a. So in both of these forms, a does the same thing. So your a value, what do numbers in front do to our quadratics? They stretch, they compress, or they split. Does standard form have that h and that k in there? No. So you can't look at standard form and just know where your vertex is. Standard form is really nice for story problems, for like making things easier to plug into a whole bunch of stuff, but it's not very nice because you can't see the vertex. So in order to find the vertex, because whenever you work with a quadratic in your graphing, step 1 is always find the vertex. To find the vertex in standard form. So your vertex is still there. It's just kind of hidden in those variables. You always find your x variable first, and it comes from a little formula. We're not really going to talk about where this formula comes from, but it's just negative b over 2a. So to find the x value of the vertex, it's x equals negative b over 2a. And then the nice thing, if you know your x value, how do you find the y that goes with it? You just plug in your x. So when you're looking for your vertex, because the vertex is a really important part of all quadratics, you find your vertex by just doing that negative b over 2a. If you like writing it as an ordered pair, and you'll see this a lot, the x variable is negative b over 2a, and then the y variable, this is just function notation, because you guys know f of x is the same thing as y, right? So what this says is just f of negative b over 2a, which literally just means you plug it in, and it'll tell you the y that goes with it. A couple other like little FYIs. So if we have a quadratic, regardless of what form it's written in, does it still have an axis of symmetry? Yes. So the axis of symmetry is not going to change. If it's written in this form, though, which of these variables is always your axis of symmetry? The x variable or the y variable? The x. So your axis of symmetry, this looks really weird, but it's just going to be the x variable of your vertex. Just in case you run across that, that negative b over 2a is always just your vertex. And then, this was kind of a bad picture for me to do this to. There's one other thing. So standard form actually gives you something that vertex form can't give you, and it's the y-intercept. You guys know when we're graphing linear stuff, the y-intercept is important. These graphs still have y-intercepts. At the y-intercept, what does x equal? 0. So imagine if you just plug a 0 in for these x's, what's anything times 0? 0 plus 0, 0. So if you are given standard form, the y-intercept, if you plug in all these zeros, what's the only thing that's going to be left? C. So the y-intercept ends up being that c value. It's not a huge thing, but it can kind of be helpful at the end to check your graph. So we're just going to graph these from standard form rather than vertex form, and there's not too much of a difference. So now you can glue in that one graph. And then write this equation down next to it. Whenever you graph any quadratic, regardless of what it looks like, whatever form it's in, step one is always find your vertex. Yesterday was really easy because vertex form, you can just look at it and you know what your vertex is. To find the vertex of these ones, not in vertex form, it's all multiplied out, we have to first find the x value, which is negative b over 2a. So when you look at this, a is just whatever is with your x squared, b is with x, c is by itself. So in this case, negative b, you'll also hear it called like opposite b. What's the b value in this equation? 4. So then when we plug in to find the vertex, what will it turn into? Negative 4. So it's opposite b over 2a. What's our a value? 2. Orders of operations, you multiply first. What's 2 times 2? 4. So what's negative 4 over 4? That means at your vertex, the x value is negative 1. So that little formula gives you the x value of your vertex. You can't see it just looking at it, so you just have to use that formula. But once you know the x value, if you know your x, how do you find the y that goes with it? Plug it in. So we're just going to take y equals 2, and then our x we know is a negative 1. And then I don't care if you use your calculator. I don't care if you work it out on paper. You need to do what's going to work for you. So if you can't do these on paper, you use a calculator. If you don't want to use a calculator and you don't want to do it on paper, you need to change your attitude because you need to know how to do this. Orders of operations, what's going to happen first? Exponents, what is -1 squared? So we have 2 times 1 plus 4 times -1 plus 1. Now we have multiplication. 2 times 1? 4 times -1? Plus 1. So what's 2 minus 4 plus 1? -1. So we just did all of that work, and all we did was find the vertex. So the vertex of this parabola is at -1, -1. The nice thing about this problem, everything else is the same from yesterday. So whenever you graph a parabola, step 1 is find your vertex. We just did that. And now we have to put on the sides. Whenever we put on the sides, remember it always goes 1, 1, 2, 4, 3. So that's always the counting pattern for the sides. Look at our original equation. Do we have anything changing that counting pattern?
Yeah.
Yes, we have an A value. So anytime you have a number in front, doesn't matter what form you're in, if it's in front of that x squared, what part of the counting pattern does it multiply with? The second part. So what's 1 times 2? 4 times 2? 9 times 2? So that means from our vertex, which we already have down there, now we just go over 1 up 2. Over 1 up 2. Over 2 up 8. And then can we fit the 318? No. Was that any different from how we did it yesterday? No. So literally the only difference is how you find the vertex. If it's in vertex form, you can see it. If it's not in vertex form, you have to use that little formula. Our axis of symmetry is the line that would cut this guy in half. Where is it? X equals -1. It's a vertical line. It has to go through -1. Does this graph have a minimum or a maximum? Minimum, where is the minimum at? -1. Again, y equals -1. That's the bottom part of the graph. So you'll reuse the vertex numbers. Domain, you can write D for domain. Does the domain of quadratics ever change? No, that's easy peasy. Does the range change? Yeah, so start. Where is this graph low to begin with? We can equal -1, it's a number. How high will it go? Infinity. Then one new thing you can do with these ones that you can't do with vertex form is we can find the y-intercept. So your y-intercept is C. It's your C value. So up in this equation, what's our C value? 1. I like using the y-intercept as your final check, because if I look over to this graph, where's my y-intercept at? 1. So if you can look and find your y-intercept and know the y-intercept's at 0, 1, look at your graph, and if that's in the right spot, your graph is probably correct. If it's not, you probably messed up somewhere. Yeah. Or you're just stretching. Okay, so graphing-wise, do you see how the only thing that's different is how you find the vertex?
Yeah.
All you have to remember is that x equals -b over 2a. Plug it in to get your y. Everything's the same. Standard form and vertex form have two different kind of reasonings for them. So depending on what you're being asked to do, you might want it in one form or another. So we're just going to do 2 more examples, and we're just going to practice writing them in the different ways. So this guy, copy it down. And just looking at it, is it in vertex form or standard form? Vertex form. So to switch it into standard form, really the main difference is just they don't have that parentheses. Before we distribute, this is really the main thing, right? We have to get rid of that squared. So that does not mean x squared plus 4. What that means is how many of these x plus 2's do we have? 2 of them. So just off to the side, that really means x plus 2 times x plus 2. So in order to multiply two parentheses together, we have to FOIL. So first ones together was x times x squared. And now you do x times 2. Is there anything left for this x to multiply with? No. So now you do the inner ones. What's 2 times x? And then what are the last ones that multiply together? 2 times 2 is 4. So that's foiling. Do we have any like terms that can be combined? What's 2x plus 2x? So the thing that's kind of weird about this, that is just that part right there. We haven't dealt with the 3, we haven't dealt with the plus 1. So we just have to kind of plug that back in. Because the main thing is you have to multiply out those parentheses. Easiest to do it off to the side. What would be the next thing we can do? Now we can distribute in that 3 because we got rid of the squared. So 3x squared, 3 times 4x, 3 times 4, 12, and then we still have that plus 1 on the outside. Is there anything else that we can combine together? So they're standard form. This form and this form, they're equivalently the same.
It was minus. Yeah.
Oh, my little, yeah. Right, my circle made me think it was a plus. So then instead of a 13, that should be 11. Good catch. Those two forms are the same. So depending on what we're doing, you might want it in one form or the other. Questions. I think this is the harder way to go through. So if you're given vertex, to make it into standard, you have to multiply it out. We're going to do one going the other way. So now what if we're given standard and we want to write it in vertex form? This is the last one we'll do for nodes. The reason that it's called vertex form, why is it called vertex form? Yeah, it's called vertex form because you can see the vertex. So if we want to write this in vertex form, what should we probably find first? The vertex. What formula gives us the vertex? So we want to get it in vertex form, which means we better find the vertex. That's the whole reasoning behind the name. What is opposite B here? It'll be 8. Since it's a negative already, it goes opposite in this little formula. What's our A value? 2. So what's our X value of the vertex? 2. So there's the X value of the vertex. How do you find the Y that goes with it? Plug it in. Orders of operations. 2 squared.
4.
Orders, now we have to multiply. 2 times 4. 8 times 6, 2. And once you get it to all adding and subtracting, it should be pretty clear. You have 8 minus 16. Negative 8 minus 1 more. So that x and that y, what point is that of our quadratic? The vertex, which in vertex form goes in for which variables? H and k. So we know that it's x. Since this is a 2, what is it in the parentheses? And then minus 9. So the only thing we're missing is our a value. And that's actually the easiest thing to find because is there any difference between the a values? No. So in this case, what was our a value? 2. So in this case, what's our a value going to be? 2. So the a values never change. A is always a. So whatever your front number is in one form, that's going to be your front number in the other form. never took a accounting class. Good at like money accounting and accounting. You know how hard it is to like keep track when I'm thinking of other stuff.
You know how hard it is to like keep track when I'm
Oh, that's why everyone gets bored. I never.
I don't get grades. Nobody.
Oh,
That's what you. Yeah. And my sister used
We'll make sure.
Oh, you don't have to do it.
Alright, look on the front side. For number 3, is there one of those that you guys want to do together?
1 through 3.
On number 3,
Oh.
I'm going to do one of each part, so. You want to do F?
No.
E? E? Yeah. Alright. So for part number 3, it says for the following questions, identify the vertex, axis of symmetry, y-intercept, maximum or minimum value, and the domain and range. Do not grasp. So really, the main part of all of these is step 1, find your vertex. In this case, can we just look at it and know the vertex, or do we have to use a formula? Look or formula? Formula. So, no matter what, if you're looking for the formula, if I am doing homework and that doesn't make sense to you or you don't care, don't be distracting to people that do care. You can make that choice to not pay attention and just work on your own, but there's probably people around you that are still confused and are probably trying to pay attention. If you are given standard form, make sure you do this formula. What is negative b here? 4. So it's always the opposite sign of b. Since that's already a negative 4, it's going to turn positive. What's our a value? 3. What does 4 over 6 reduce down to? You should keep that as a fraction, but know that I'm assuming you have a calculator in front of you. So there's nothing wrong with you getting fractional answers because you're allowed to use calculators in here. So that's the x value of the vertex. How do you find the y value that goes with it? You still have to square it first. The nice thing about when you square a fraction, what do you think it's the square, top, bottom, or both? Both. So this is really just 2 squared is 4, 3 squared is 9. So squaring a fraction isn't bad. It just, you square both parts. And then when you take a fraction times a whole number, what number is really underneath this 3? A 1. So that 3, it doesn't multiply with both the 4 and the 9. It just multiplies with the 4. So what's 3 times 4? So that's really just 12 nines. Minus, so what's 4 times 2/3? 8. So that's just 8/3. So here's my assumption. You have a calculator in front of you. You guys can put fractions into your calculator. You can write a decimal answer if you really need to, but if you can do this without, go ahead. Between 9, 3, and 1, in order to add and subtract, you need a common denominator. What's the common denominator of 9, 3, and 1? 9. So this fraction is good. What do you have to take 3 times to make it a 9? So what's 8 times 3? What do you have to take 1 times to make it a 9? If your denominators are all the same, those are just going to stay. So the top takes the operation. Negative what? Honestly, didn't hear. So 12 minus 24 minus another 18. Negative 30. What number goes into both 30 and 9? So this is what I mean by, I assume in Algebra 2 you guys know your skill set. If your face is confused right now, you should have a calculator in front of you when you go through these. There's nothing wrong with using a calculator. Because either way, you're going to get that your vertex, what was our x value of the vertex?
2/3.
Y value. And really, once you have that, there is absolutely zero difference from what we did yesterday to what we did today. For the axis of symmetry, it's always going to be a vertical line. What point does it have to pass through? 2/3. It doesn't even matter. It's just going to be whatever that number is. Going back up to the very beginning, is this parabola opening up or down? With a positive number in front, where is it going to go? Up. So does that have a maximum or a minimum? It has a minimum. Where does the minimum have to be at? Yeah, it's always just going to be whatever that y value is. The y-intercept, that's the new one. Up in this equation, which of those spots is your y-intercept? The C. So that's just going to be at 0, -2. What's the domain of all quadratics? The range, since this guy is going up, what's the lowest point at? -10/3. And then how high up will it go? So this is the jump of the algebra 2 is not going to change. Those rules are never going to change. You have to know the rules well enough where you're comfortable with writing fractions down for the answer. That's really all it is. You guys know all those rules. The only thing that's different is you might have a fraction right there. On the back side, I'm going to do 4D. Whenever you have to graph, regardless of what form you have, step 1 is to find your vertex. If you're given standard form, how do you have to find your vertex? X equals. If you can remember that, you're set. Because look at the equation for 4D. What is our opposite B? 12. What's our A?
4.
So we have 12 over 8. What does that reduce down to? 3 over 2. Once you have your x, how do you find the y that goes with it? Plug it in. If you have a calculator and you use parentheses, you can just plug it all in one step. So I am not going to do the y for you. You guys need to do that yourselves, because don't watch me. Just grab your calculator and plug that in. What do the calculators say? It's 0. So that means where's your vertex at? So 3 over 2, which is 1.5, 0. So it's okay to get a decimal, to get a fraction. It doesn't change the process. That process is never going to change. If you can't get that to equal 0 on your calculator, you need to ask for help in how to enter it into your calculator. Once you have your vertex, what do we have to put on next? There's only one other part of this, the sides. So we know the counting pattern is over 1 up, 1 over 2 up, 4 over 3 up, 9. So that's the normal counting pattern. Do we have anything that's going to change it here? Yes. What number? The 4. So anytime you have a front number, what part will it multiply by? The first one or the second one? The second one. So it's 1 times 4. 4 times 4. 9 times 4. So that means from our vertex, you can just count over 1 whole box. So it'll still be in the middle and then up 4. Do I even have space to get our 216 on there? No. Are there any other points that I can get on there though? Yeah. If you want help, and you're not sure if you're going to connect this through right, this point right here, what is the positive 9? Your y-intercept. So you know that it's a point up there. So if you just want another like guide point to help get you through it, there you go. So the only difference today is how you find the vertex. Yesterday you could just look at it and know. Today you have to do some math. It asks you to label some stuff. Where's the axis of symmetry? X equals 3/2. Do we have a maximum or a minimum value? Minimum value. If you want to label it on your graph, that's fine. There's your minimum, and it's at y equals 0. It asks you to label the y-intercept, right? So we know that's up here. And then the last ones are domain and range. What's the domain always going to be? Range-wise, where's the low part of this graph? High part. So on this sheet, you might get some fractions. That doesn't matter. The process does not change. So yesterday you had vertex form. Today you have standard form. Tomorrow we're going to review the two. So if don't turn anything in today. Tomorrow we'll start class by kind of going through both of them, switching between, making sure we're good, and then we'll do some practicing. My mindset is the rest of today, so 15 minutes today, 50 minutes tomorrow, and then I'm not going to give you any new homework. No, I wouldn't worry about that. Our quiz is next week. So I'm not giving you a new assignment for the weekend. There will be an opportunity for you if you want, but tomorrow we're just going to do review stuff in class. So nothing new tomorrow. So if you're kind of confused right now, just work through it as best you can. And tomorrow, when I ask for what questions you have, you better have one circled. Like, I don't know how to do 7E, stuff like that. Okay.